Hello, welcome to Prajim Technologies. I am Venkat. This is part 2 of .NET Basics. In this session, we'll understand about these two tools, Intermediate Language Disassembler and Intermediate Language Assembler. Now in part 1 of this session, we have understood that when we compile any .NET application, an assembly gets generated. And we know that assemblies generally have the extension of .dll or .exe depending on the type of the application that we create. For example, if we create a Windows or a console application, a .exe is generated, whereas when we create a class library project or a web application project, a .dll is generated. Now, irrespective of whether it is a .exe or a .dll, an assembly consists of manifest and intermediate language. Now we know that when we compile the application, intermediate language is generated. For example, if you look at this example, now this is the source code. This is a C# project which I have created, and all this project does is prints out this message onto the console. Now you look at the source code here. You look at the source code here. But now when we compile this, by right clicking on the solution and say build solution, so the project gets compiled. So this source code now is packaged up into an assembly. Since this is a console application, the assembly will be .exe. And to look at the assembly, just right click on that project and open the folder in Windows Explorer, get into the bin directory and debug, and you should see the assembly there. Now this is your high-level language, your source code, and when you compile that using C# compiler built into this Visual Studio tool, you have intermediate language generated and packaged into this assembly. Here in this project I just have one class file, but in reality we may have several other class files. All these files basically will be packaged up into this particular assembly. And this assembly contains the intermediate language. Now if you look at this, this is the source code, but if I want to get a feel of how the intermediate language looks like, are there any tools to disassemble this assembly and then look at that intermediate language? And that's what is the purpose of ILDASM, Intermediate Language Disassembler tool. And to use that tool, you have to get into the Visual Studio command prompt. So to get to the Visual Studio command prompt, click on Start, get to All Programs, and Microsoft Visual Studio 2010. If you have 2008 or whichever version of Visual Studio you have, you can get to that version as well. But let's get to Visual Studio 2010, and within that you should see Visual Studio Tools. Expand that folder, and there you should see Visual Studio Command Prompt 2010. Right click on that, Run as Administrator, and that should open up the Visual Studio command prompt. Now if you look at the assembly, this particular assembly, Introduction to C#.exe, this assembly is present in this particular path. So we need to get to that path, or we need to give the full path of this assembly. So let's give the full path of this assembly. Let me copy that, go into the Visual Studio command prompt, and then type in ILDASM.exe. .exe is optional, and then paste the path. That is just the path. At that path, the name of the assembly is Introduction to C#.exe. Copy that, paste that here. Now when I press enter, this ILDASM tool opens this window, and if you look at this, the assembly, any assembly in .NET basically consists of two things: the manifest and the intermediate language itself. We'll talk about manifest in a bit, but let's look at the intermediate language and understand how it looks like. Now if you look at this, in this assembly, I have a class called main class, and within which I have a static main method. So there is this Prajim namespace. So when you expand the Prajim namespace, within that I have this main class, Prajim.main class. And within that main class, I have a constructor which is automatically provided by .NET. You don't see it here, but for this main class, if you don't provide a constructor, .NET will provide one automatically. So that's that constructor. And this class has got a static method. Look at this. There is a main static method. That S indicates static method. Okay, and if I just expand, double click that, look at this. This is how your intermediate language looks like. For example, this is the string, and we want the string to be, basically printed load str, load string. So this is how basically your intermediate language looks like. So this is your high level language C#, and this is your intermediate language for this method. Okay, so that's intermediate language. Now what is this manifest? Manifest basically consists of the metadata about your assembly. Okay, what do we mean by metadata? Metadata means information about information. So this manifest basically contains information about this assembly. For example, what is the name of this assembly? If you look at this, the name of the assembly is Introduction to C#. Okay, and then what is the version of this assembly? Now we haven't spoken about versions yet, but we'll be talking about them, which is very important, especially for solving the DLL hell problem. So we'll be talking about what is DLL hell, how to version as assemblies, what is the difference between weak named and strong named assemblies in a later session. But for now, understand that this is the information about the assembly, the name of the assembly, what is the version of this assembly. Now if you look at this particular project, this project has got this properties folder, and when you expand that, there is another file called assemblyinfo.cs. and when I get into this file, okay, when we were talking about C# video tutorial, in that we have spoken about attributes. For example, we have seen how to use, basically deprecated attribute. Okay, so there are several attributes like that, and here in this file you see assembly version attribute. Using this attribute, you can actually change the version of this particular assembly. For example, I can say, okay, this assembly, I want that to be 2. Now if I go ahead, let me close this, otherwise we'll get an error. So let me close this and build the solution. Okay, so build succeeded. Now if I come here and run the same command once again, and look at this, look at the version of the assembly right now, version 2. Okay, so whatever you're specifying in your source code, the information about that particular assembly will be present in this manifest, the name of the assembly, the version number, and the types within that assembly. For example, if you look at this project has got like just one type, which is main class. Okay, but in reality there will be several classes and structures and other things as well. So entire information about what are the different types and their return types, etc., all that information about this assembly will be present in this manifest. Not only that, this assembly, we'll talk about this in a later session, but basically an assembly might depend on other assemblies for some of the services. For example, if you are developing a web application, and to make any security related programming, you basically use system.web.security namespace. Okay, so basically the classes that are present inside that assembly. So your assembly might depend on other assemblies. Okay, so when your assembly is depending on other assemblies, okay, on which other assemblies is this program depending upon, and what is the version of that assembly, etc. Okay, all this information is basically present in the manifest. And why is this manifest very important? Because at runtime, when your program executes, okay, all the dependent assemblies had to be loaded. Okay, the correct versions of those dependent assemblies has to be loaded. And how does your program decides that? Based on the information that is present in this manifest. So that's why manifest is extremely useful. So we have seen how to use this ILDASM tool to disassemble and peek inside an assembly to look at its manifest and intermediate language. Another use of this tool is basically to export this intermediate language to a text file if you wish to. And to do so, what you basically can do is select File and then select this Dump, and then it shows you this dump options window. Just click OK, and then it will ask you to save this IL file somewhere. Okay, I've already saved this here. Let me delete that. Okay, I want this file to be saved to this C drive, and I'm giving it sample.il name, and then click Save. So it's already there. I am just replacing it. So it gets saved there. Now if I go to the C drive, if we go to the C drive, there is a sample.il file. Now you can open that with Notepad. So let's open that. So start, run Notepad, and drag and drop this IL file onto that Notepad. Look at this. The entire intermediate language and the manifest of that assembly is present in this Notepad now. I mean in this text format. Okay, now let's say for example you have intermediate language in this format, in the text format, and you want to reconstruct your assembly back. Is that possible? Absolutely. And how do we do that? There is another tool for that, which is nothing but your ILASM, intermediate language assembler tool. And the way we use it, exactly the same way. Open up Visual Studio command prompt, and in the command prompt type ILASM .exe, and .exe is optional again, and then give the fully qualified path of the IL text file that is there. And we know it is actually present in c:\sample.il, and press enter. So what is this ILASM tool going to do? It's going to read the contents of that file and reconstruct an assembly for us. Okay, so operation completed successfully, and if we go back to C drive, you should see sample.exe, and if I run that now, you should see your program executing. So basically, in short, we use ILDASM, intermediate language disassembler, to look at inside an assembly, to look at its manifest and intermediate language. And we use ILASM basically to reconstruct an assembly from intermediate language that is present in a .il file. And we'll talk about strong named and weak named assemblies in the next session. On this slide, you can find resources for ASP.NET and C# interview questions. That's it for today. Thank you for listening. Have a great day.